Hello and welcome back. We are ready for chapter 2, section 9, the last section of this chapter. So we finally made it to the end of chapter 2. Today's lesson is about absolute value functions, and the objective is to graph and transform absolute value functions. All right, you only have one vocabulary word, and that's absolute value function. So we're going to get started working on that. Okay, so an absolute value function is a function whose rule contains an absolute value expression. The graph of the parent absolute value function f of x equals absolute value of x has a V shape with a minimum point or a vertex at 0. So I just thought I would prove this up to you a little bit. Let's just call this one x and this y and make a T-chart of this. So when x is in our function is going to be f of x equals the absolute value of x. So let's see, when x is 0, y is 0. When x is 1, the absolute value of x is also 1, because remember that's the same distance away from 0. When x is 2, the absolute value is 2. It's 2 units away from 0. What about when the absolute value is -1? Well, when it's -1, the distance from 0 is still 1. And when our x is 2, the absolute value of 2, how far is it away from 0, is 2. And when x is -3, again, we're still 3 units away from 0. So we can plot this, and when we do, we see that we have a graph that looks like this, and it's a V shape. And so that is your parent function for f of x equals the absolute value of x. All right, and notice that the vertex is at 0, 0. All right, so here's a little bit nicer picture of it. Just want to let you know that the absolute value parent function is composed of 2 linear pieces. One with a slope of -1, so that would be this piece going down, and one with a slope of 1, so that's this part coming up. In lesson 2.6, you transform linear functions, and you can also transform absolute value functions. And this will be easier, I believe. All right, so just a few things to remember when we're doing translations. If we're doing a vertical translation, we're dealing with the y. Remember, f of x is the same as y. And then we're just going to add a k to it, or whatever, 2, 3, whatever. And if we're doing horizontal, it's going to take our x inside parentheses and then subtract our h or whatever number you choose. All right, so let's get started and we'll see how this works. This is example 1a, translating absolute value functions. So it says perform the transformation on f of x equals absolute value of x. Then graph the transformed function g of x 5 units down. Okay, so let's just go ahead and do the 5 units down. So 5 units down tells us that we're dealing with the y. All right, so, and it says that we're going to go 5 units down. So we're going to remember that f of x means output, and it also means the y is also our output. So these two both mean output is is the same thing. So you could call it either way. We tend to call it f of x. And so if we're going down 5 units from y, then we just say y minus 5. But instead of saying y minus 5, we're going to say f of x minus 5. All right, so now we're going to do some more substitution. Up here, we see that f of x equals absolute value of x. So instead of saying f of x here, we're going to say absolute value of x minus 5. And so our new function is going to say g of x is equal to absolute value of x minus 5. All right, so let's think about what this is saying. All we're doing is going 5 units down. So if our original parent function starts at 0, 0, and we go 5 units down, 1, 2, 3, 4, 5. Our new graph is going to look like that. So we'll just look at that. Here's our parent function. And then our new function is 5 units down. All right. Next, perform the transformation on f of x equals absolute value of x. Then graph the transform function of g of x in 1 unit left. Okay, so remember, we talked about when we're going horizontal, we have to think, remember I told you we think about horrible horizontal. All right, so we're going to move 1 unit left. So let's see what that looks like. Goodness. Okay. I'm going to go left. So I'm going this direction. So I'm actually going to add, and I'll show you what that, we're going to talk more about that in a little bit so you'll understand it a little more clearly. So we're going to add to our x, okay? So we're going to say, keep our absolute value of x, and we're going to add 1 to our x. So our new function is just going to be g of x is equal to absolute value of x plus 1. All right, so let's look at what that would look like on a graph. Here we see that, let's see, our parent function is right here again. And now it says that we are going to shift over 1 unit left. So we're hoping to end up right here. And it says our vertex is -1, 0. And so there it is, and it shifts over 1 unit, and that's exactly what we want it to do. All right, let's do another example. All right, it says let g of x be the indicated transformation of f of x when it equals absolute value of x. Write the rule for g of x and graph the function 4 units down. Okay, so to go 4 units down, we're going to be using our vertical. So we're going to go vertical. Okay, so we're going to say y minus 4, or better yet, f of x minus 4. And we already know that f of x is equal to absolute value of x, so we're just going to replace that and say absolute value of x minus 4. So our new function is g of x equals absolute value of x minus 4. So let's look at what the graph of that would look like. We're just going 4 units down. So here is our parent function, and quickly went on down. So our new function is just 4 units down. All right. Perform the transformation on f of x, then graph the transformed function g of x 2 units right. Okay, so we're going to go 2 units right. So again, we're back to horizontal. Oops. Let's see if I can get this. All right, we're back to horizontal again. And this time we're going to go 2 units right. So let's just get a picture in our mind of what that's going to look like. We're going to go 2 units to the right. So we're going to go this way. So that means we're going to actually be putting a minus sign on it. All right. So our x is going to be x minus 2 has to stay together. All right. So we're going to keep that inside our absolute value together, keep it together with our x. So our new function is just going to be g of x is equal to absolute value of x minus 2. Okay, so don't know why I have an empty graph there. Oh, there it is. Okay, and first of all, we want to always plot our parent function. So here's our parent function in blue. And the question told us to go 2 units to the right. So that means our new vertex is going to just move over 2 units to the right. And there it is. Okay? All right. And now it's animated for us. All right. So let's just look at this. Because the entire graph moves when shifted, the shift from f of x equals absolute value of x determines the vertex of an absolute value graph. Okay, so I want you to really pay close attention to this because this is going to be very helpful. So I'd like you to put this in your notes, please, and I will ask you to show them to me. So I want to make sure that you get this very clear. Okay, so g of x is equal to the absolute value of x minus h plus k. So when you see this format, we are going to say, just like we know that y equals mx plus b, we know what the y and the mx and the b all equal. Well, same here. When we have an h and a k, that is going to be where our vertex is. All right, and this is going to make it really, really easy to find our absolute value graph because all we need to do is find our vertex, and it's going to be at h comma k. All right, so let's do a sample of that, and I will show you how easy that is. All right, so it says translate f of x so that the vertex is at -1, 3. -3. So let's just start for a minute, and I'm going to start out and show you where our parent function is going to be. It's going to be right here, and that's what our parent function is going to look like. All right, so but it just says that we want to translate it to -1, -3. So we're going to go over 1, down 3. Okay, so let's do it the old-fashioned way first. All right, so first of all, we do a horizontal shift. We're going to the left, okay? We're going to the left, so we're going to add to our x, because that's a horizontal. So we're going to say x, and we're going to go 1 over. So we're going to say x plus 1. And we're going to keep that together because now we're going to do a shift down. So we're actually going to say -3. All right. So now our new parent or our new function is right here. All right. So an easier way that you could have done that now that we know our formula, and remember our formula says g of x equals x minus h plus k. All right, and so all we really needed to do on this particular problem is say g of x equals x minus a -1, all right, plus k. So minus a -1 is actually plus a positive x plus 1, and that stays in our absolute value, and then plus a -3, which is exactly what we said our g of x would equal. All right, so all you have to do is plug your two numbers in. This is h, and this is k, and this is h, and this is k. So that makes it a little more simple. And our next page is going to show us what that actually looks like on a graph. First of all, we have our parent function, and then we're going to move the vertex down over 1, down 3, and there it is. All right, so next thing that we're going to look at is, let's see, translate f of x equals absolute value of x so that the vertex is at 4, -2. All right, so 4, -2. Now let's just do it the easy way. So let's remember g of x is equal to x minus h plus k. All right, so we just have to say, and let me change these to absolute value sign. Yeah. So let's do it like this. Okay, so let's say x minus, and this is our h and k in this particular instance. Don't know why I cannot do my pencil. All right, so x minus 4 plus negative 2. So that's all we have to do to write the new function out, is just fill it in. Okay, we could also have thought about where it would be and do it the long way. So it start out here, we're going to go over 4, 1, 2, 3, 4. So we're going to the right, actually, so we have to minus, which we did. And then we're going to go down 2, 1, 2. So that's our subtract 2 right there. So you can see that our new point is going to be here. All right, and let's just take a look at that. Here's our parent function, and then when we shift it, it just goes right to over 4 down 2. Okay, let's move on. All right, so absolute value functions can also be stretched and compressed and reflected. Just like we did the shifts, now we can stretch and compress, and it's going to be the exact same thing. So if we're reflecting across the x-axis, remember we're moving from this side over to here to this side. So our x's are going to be opposite each other. All right, and that's if we're going across the x-axis, which would be right here. So our x is going to be opposite. If we're shifting or reflecting across the y, our whole y, remember f of x means output, and so the output in y is also our output. So if we're reflecting across our y, the whole y has to be negative. And for vertical stretch, it's the same thing. For vertical is very good. You don't have to worry. You just multiply your vertical times your whole f of x or y. But for the horizontal, we have to, again, multiply it by 1 over b, whatever your stretch or compression number is. All right, so example 3a, transforming absolute value functions. We're going to perform the transformation, then graph. And so we're going to reflect the graph of f of x equals x minus 2 plus 3 across the y-axis. So first of all, let's figure out where that is. So I am going to tell you now what I always do to find my vertex, although they told us it was going to be 2, 3, because our formula, this is the way I like to think about it. What number can I put in here to make this 0? Well, I know that positive 2 minus 2 is equal to 0. So when x is positive 2, y is actually 3. 1, 2, 3. So we can see 2, 3 is our vertex. Okay, so but the question says to reflect the graph across the y-axis. Okay, so the y-axis is going to be right here, so we're going to go across this way. So our x is going to be negative now. So we're going to say, let me say g of x instead of f of x. G of x is going to equal the absolute value of just the the x value minus 2 plus 3. All right, so that is your new function, and I'm just going to show you what that looks like. It's kind of just moved over. It's hard to see that it is reflected, but let's look at it, take a look at it anyway. Okay, so it just moves over. It's reflected, and you can't really tell a reflection because it's symmetric. All right. I think this is our last one. So this one says to stretch the graph f of x equals absolute value of x minus 1 vertically by a factor of 2. Okay, so we're going to be going vertically. So that means we're going to be dealing with our y. And y, remember, is the same as f of x. So we're going to multiply by a factor of 2. So 2 times our f of x. Well, it turns out that our f of x is actually absolute value of x. So we're going to say 2 times the absolute value of x minus 1. All right, so that's the whole f of x is absolute value of x minus 1. It says we're going to stretch it vertically by a factor of 2, so we just have to multiply 2 by the whole thing. So let's just go ahead and distribute this. 2 times absolute value of x is 2 times the absolute value of x, and then minus 2 times 1 is 2. And so that is our entire thing. So g of x equals 2 absolute value of x minus 2. Okay, so once again, we can take a look at this, and we see that with our x is negative 2. And so let's go ahead and plot this. All right, so the vertex is at 0, 0 for our parent function, but this function, they told us, is vertical stretch by a factor of 2, and so there's the new one. So here's our f of x equals x minus 1, so we see that that moved down 1, and then this one was a vertical stretch by a factor of 2. All right. Oh, we have one more. Okay. So our last one is a pretty interesting one. It says compress the graph of f of x equals absolute value of x plus 2 minus 1 horizontally by a factor of 1/2. So we have to be careful about this one now. Okay, so horizontal means we're going to take x and we're going to say 1 over 1/2. All right, so this would be f of 1 over 1/2 x. All right, so let's get this part in first. So if we multiply the top by 2 and the bottom by 2, we end up with f of x is 2x, all right, plus our 2, and all that's in our absolute value box, minus 1, and that's all we have to do, g of x. All right, so let's look at what where our points are on here. This is going to be our h, and this is going to be our k. So our h is at 2 over 2, because when x is 0, y is, we have 0 plus 2. Let's see, so we're going to go over 2, down 1. I think I did that right. Let's just click on that and see. Oops, I went the wrong direction, but now you can see where it should be. Okay, so here is the graph of g of x, absolute value of 2x plus 2 minus 1, and then the compression after that. All right, last one, I think. Keep on thinking. All right, perform the transformation, then graph. It says to reflect the graph, f of x is the opposite of the absolute value x minus 4 plus 3 across the y-axis. Okay, so we want to perform the transformation, and so this says to reflect the graph across the y-axis. All right, so let's do that. When we go across the y-axis, again, our x is what changes. So we have opposite of negative x minus 4 plus 3. And that is actually our whole function. F of x equals negative absolute value. It looks like a 1 there, but it's actually the absolute value. All right. So let's see if we can figure out what this one would look like. This is our h, and this is our k. So h is going to be 4. When x is 4, that makes this whole thing 0. So when x is 4, that's 0, and then the k is plus 3, so we go up 3. So here it is. Now this negative, just like a negative slope, this negative tells us that our absolute value is actually going down. All right. All right. So we're reflecting across the y-axis. So here we had over 4 up 3. So now we're going to go over negative 4 up 3. So our new point, our new one, is going to look like this. And you will see on the graph on the next page that it looks a little crazy because it ran out of room, but that's what it would look like. So that is the end of this lesson. It was a little bit short, but we'll be going over more problems in class together. So make sure that we understand it before your test, which is coming up. And today's Bible verse is about endurance. We have really endured through this chapter 2. Produces character, and character produces hope. So I hope you're having a great day, and I will see you soon.